Hello class and welcome back to AP Computer Science Principles. Today we are going to talk a little bit about how computers actually communicate with other computers. Like, how do they get the strings of ones and zeros that, as you know, everything in computer science is made of, and how do they transmit that over wires or potentially wirelessly from one computer to another computer? But before we do that, I would like to introduce you to a new way of communicating that is not practical at all, but will give you an idea of how this is supposed to work. So let's say I am trying to communicate with you, and I am only communicating a message in zeros and ones, right? Binary. I could use like a flashlight. And I could, for example, say that the flashlight being on is a 1 and the flashlight being off is a 0, and we can establish some sort of timing. Let's say that you're receiving my message and we both know that every second is a bit. So if the light is on during that second, then it's a 1, and if the light is off during that second, then it's a 0. So I have a 60 BPM metronome here, which will make a tick sound every 1 second. There might be some weird delays with exactly when the light, but it doesn't matter. So like, if I wanted to make 1001101, it would look something like 1001101. Something like that. So again, so long as both you and I know the cadence and which one stands for 1 and which one stands for 0, right? On for 1, off for 0. So long as we understand those rules are called protocols, by the way. We'll talk about that later. So long as we both understand, then I can get a message across to you. But it's not the fastest thing out there, is it? Especially if it's only doing binary. 1 bit per second is the speed that I am transmitting that information. Every second is 1 bit that I am transmitting to you. But, of course, we use electrical impulses and flashes of light through either copper wire or fiber optic wire. This leads us to our first vocabulary word for the day, and that is bit rate. Bit rate is exactly what it sounds like. It is the rate at which you are sending bits. How many bits are you sending every second? In my little demonstration, I was sending 1 bit per second, so that would be my bit rate. To put all of this into context, the very earliest internet connections moved at a rate of about 75 bits per second, which sounds like a lot, but it's really, really not. When I was a kid, we had a dial-up modem, one that you actually had to like plug into the phone and nobody could use the phone while you were on the internet. They were dark days back then. And I maxed out at about 56 kilobits per second. I'm going to go ahead and put the table of what each of these prefixes means up for you because it has been a while since we have reviewed that, but a kilobit is 1,000 bits or 1,000 ones and zeros. So 56,000 bits per second approximately. You may at some point have heard the term broadband, although it's not said as much anymore as it used to be. Anything more than 256 kilobytes per second is classified as broadband. Again, that is a very, very small number compared to what we have now. In fact, here in the United States, the median download speed is 242-ish megabits per second, so 240 million plus bits every second. Now, not everyone in the world or even everyone in the United States actually gets to take advantage of that high-speed internet, but that, my friends, is a conversation for another video. So, bit rate is how many bits per second are being transmitted and received. Fantastic. So how is that the same and different from bandwidth? Bandwidth is a word that you definitely have heard if you've ever shopped around for internet service. And bandwidth is different from bit rate in kind of a weird way. So bit rate is like how fast your connection is going right now. Whereas the bandwidth is the absolute maximum fastest that the connection could withstand theoretically. Like, Theoretically, I drive a car that can go 110 miles per hour. Don't ask, I'm not saying that I actually tested that. But assuming it can go 110 miles per hour, even though I never drive that fast, that maximum speed that it could theoretically go, that's the bandwidth. Now, here's where things might get a little bit confusing, maybe. So we've been talking about bits per second as essentially a unit of velocity, right? Number of bits divided by number of seconds, bits per second. But it's not really a velocity, because velocity is specifically distance over time, right? When we're talking about actual physical speed between two places, we're talking about velocity, and that's what we're talking about when we talk about latency. So this is another very important piece of what makes an internet connection fast or not fast. It's not just how many ones and zeros can you throw out the door. It's also how long does it take for those ones and zeros to get where they're going and for you to get a response back. Now, these days, as I said, we use copper wire and fiber optic cables that takes either electricity or light and pulses them in such a way that, again, millions of bits per second can be transmitted. But that transmission still takes time. For example, so let's say I'm sending a request to Google, maybe a search result or something. It's going to take, let's say, 30 milliseconds, and a millisecond is 1/1000th of a second, so this would be 0.03 seconds to get to Google. It's fast, it's not instant, but it's fast. And then let's say Google gets back to me with a result in 40 milliseconds. Yeah? The entire round trip of the packets, we'll talk about that later as well, that are going back and forth, 30 milliseconds there, 40 milliseconds back, my latency is 70 milliseconds. The amount of time that it takes information to go out and get confirmation back is your latency, otherwise known as your ping time. Now, latency, as well as bitrate and bandwidth, all sort of work together to make what we call internet speed. Is the internet fast or slow? It's a combination of all of these things. For example, if you're a gamer and you find that your game's lagging a lot, it's probably not your bitrate that's the problem. Probably. It's probably a latency problem. Because after all, if you're playing a multiplayer game where reflexes are really important, if it takes you maybe 100 or 200 milliseconds to actually input your command and get your result back from the game, that is a massive disadvantage when playing against other players. Now, as always, I will be leaving plenty of information down in the description for folks who want to look further into this. I may also make another video where I just read through the Khan Academy article on this. But before I left you for today, I wanted to go ahead and run a speed test at my place, hopefully with all identifiable information removed. That's another thing we're going to talk about at some point. But let's take a look at my internet connection and see where I'm at. So the first thing it's going to do is it's going to ping. I got a 9 millisecond ping time, so that's very, very quick. Now, first it's testing my download speed. How fast can bits come to me? And that's 221 megabits per second. And then the upload speed, which is how many bits per second I can send out from my connection, is actually higher. That is surprising to me. 237. Now, this result kind of surprises me and tells me that something may have changed recently, because up until now, I've always assumed that internet providers focused very hard on download speeds and not so much on upload speeds. When I first purchased this, the upload speed was only 15 or 30 megabits per second bandwidth, like the advertised maximum. And now I'm seeing 237, so I'm pretty happy about that. Okay, before we go, let's do a quick vocab review. So bit rate is how many bits per second You are either sending, that's called upload, or receiving, that's called download. Bandwidth, instead of being the speed you're going at right now, is the maximum potential speed that your entire connection could handle. Latency measures how long it takes for a signal to go from you to where it's going and back, also called ping time. And all of these factors mix together to make your internet connection seem fast or slow or somewhere in the middle. Thanks for watching. I hope I'll see you next time.